Continuing on with these instructional videos, starting with page 9, table 3. The first thing you want to do is write all of the Fe, Sc, and 2 plus equilibrium molarities from table 2 into table 3. So those numbers you're going to write in this column. So you've already calculated those on the previous page with your y equals mx plus b. We also have all of these numbers you wrote from the previous video. So we've done those two. Now we're going to use an icebox to calculate the equilibrium molarities. So use an icebox to calculate the equilibrium molarities of Fe3 plus, which will go here, and of SCN minus, which will go here. We'll look at an example of that on the next page. We're going to use an icebox to calculate the equilibrium molarity of my two reactants. I'm going to use example solution B1. So I am going to, so you have your own numbers, but the number that I am going to use here, 3.6 times 10 to the negative fifth molarity. So we can use an icebox because I'm given two initial values, the equilibrium value of one product, and I can find the equilibrium values of the other. So to use our icebox, the first thing you have to do is write your balanced chemical equation, Fe3 plus aqueous plus SCN minus aqueous in equilibrium with Fe SCN 2 plus aqueous. ICEQ. I'm going to keep track of all of our reactants and products with this. So my initial, I plug in 9.1 times 10 to the negative fourth molar, 1.82 times 10 to the negative fourth molar, 0 for the product, standard icebox template. So we plug in the values for I, your change minus X for the reactants, plus X for the product because it's a 1 to 1 to 1 mole ratio, and then EQ, add up your columns. 9.1 times 10 to the negative fourth molarity minus X, 1.82 times 10 to the negative fourth molarity minus X and X. Now, step 3, stop and think. How do I find X? I know my product at equilibrium is X, which is this number that I have here. So now that I know what my value of X, so I can say X equals 3.6 times 10 to the negative fifth molar, I can solve for the equilibrium molarity of the other products. So iron would be 9.1 times 10 to the negative fourth molar minus 3.6 times 10 to the negative fifth molar, and you put that into your calculator. SCN minus 1.82 times 10 to the negative fourth molar minus 3.6 times 10 to the negative fifth molar. And you'll do the same process for all of the other B solutions. So for the report, I want you to give one example icebox. Do not use B1 since I did that for you. Go ahead and use B2 or 3 or 4 or 5. Now finishing up table 4, calculate Kc for each B solution. So remember our values of Kc, our expression for Kc, products over reactants. And these have to be equilibrium values. So my product is the Fe SCN 2 plus at equilibrium, which you have from table 3. Your reactants, iron 3 plus at equilibrium, which you have, and SCN minus at equilibrium, which we have here. So your Kc value, you'll calculate by plugging in all of these numbers, products over reactants, and entering them into each of these tables here. You'll then calculate an average. Remember, an average is just the sum of all of the values. So add all of these K values, divide by 5 to write that number there. Deviation. So a deviation just tells you how far away from the average is each individual value. So let's say I have, this is just A, let's call my average B. The deviation is the absolute value of A minus B. For B2, let's call this C, my deviation be C minus B, etc. And then the average deviation, you just sum all of the averages and divide by 5. I hope this was helpful.